Good morning to one and all present here. I am Bhuvan and my registration number is 19BCE2043. Today I am going to talk about Einstein's special theory of relativity and frames of reference. When it comes to the human perception of space and time, we have a rather straightforward approach. Our understanding of space is three-dimensional, while our concept of time is very linear. However, what if I told you that space and time do not behave the same in all situations when we consider physics of very high velocity objects? Basically, the special theory of relativity establishes the relationship between space and time for problems that classical physics fail to understand. The whole premise upon which special relativity is built consists of two simple postulates. The laws of physics hold in non-accelerating frames of reference. The speed of light remains constant for all observers. The reason these postulates were framed was that Einstein found an inconsistency when he tried to apply Newtonian mechanics to Maxwell's equations of electromagnetism. This led Einstein to believe that Newtonian mechanics did not work according to Maxwell's equation of electromagnetism. However, it was not possible for the speed of time to be a variable, as it had been rigorously analyzed and experimented upon by numerous scientists. Although Newtonian physics were highly instrumental, when it came to everyday calculations, they failed miserably when considering high velocity physics at the speed of light. So let me talk as if I am an Einstein now, so that you would have an idea how Einstein had his thoughts during his experimentation. So what is time? A deceptively simple question, but it is a key to understand relativity. It is also the reason you're watching this video now. Mathematical description of velocity is mute until we can define time. So is time universal? The answer is no. Time is not absolute. Even for physicists, the present, past and the future is just an illusion. To understand time, we must understand relativity. Let me explain you why time is not absolute. Imagine a train racing past faster than any other train you have ever seen in your life. Now, let lightning bolts strike behind the train at the same time a few hundred meters apart. Now imagine you are standing in the middle of the train during this exact same scenario. Now watch the lightning bolts. Were they simultaneous to you? No. It's because you were moving towards one and away from the other. So what did you observe? The moving train and the lightning bolt were simultaneous while you were standing still. But you were in the train, they were not simultaneous. So how could the two situations experience the same event differently? So from this experiment, I can conclude that time is not absolute. Let me explain you another experiment of mine called elevator experiment. When the elevator was falling down, I was just floating inside it. I felt as if there was no weight at all. Because a falling person does not feel his or her own weight. I cannot feel the presence of the floor on my feet. All my papers, documents, each and everything lying around me was just flying. So what if the elevator was rising? As the elevator is rising, I would be accelerating in the opposite direction. I would feel the floor as if I am glued to it. Therefore, I can conclude that acceleration and gravity are the same thing. This is the idea I have been missing to complete relativity. Frames of reference. Imagine you threw and caught a ball while you were on a train moving at a constant velocity past a station. To you, the ball appears to simply travel vertically up then down under the influence of gravity. However, to an observer stood on a station platform, the ball would appear to travel in a parabola with a constant horizontal component of velocity equal to velocity of train. This is illustrated in the figure below. The different observations occur because the two observers are in different frames of reference. A frame of reference is a set of coordinates that can be used to determine position and velocity of objects in that frame. Different frames of reference move relative to one another. The frames of reference that appear here are classical and inertial. The effects of special relativity are ignored. The frames are not accelerating relative to one another. The laws of physics are the same in all inertial frames. This is known as Galilean invariance. Put it in other way, there is no experiment that you could determine in which reference frame you are in. Einstein used this hypothesis to devise the special relativity. This means that we can address problems in any reference frame to give an equivalent solution. There are two types of reference frames. Inertial frame of reference. A frame of reference that remains at rest and moves with a constant velocity with respect to other reference frames. A body does not change due to its external forces. There are several ways to imagine this motion. Our Earth, a space shuttle moving with constant velocity with respect to our Earth. Non-inertial frame of reference. A frame of reference when a body not acted by external forces is accelerated. Newton's laws of motions are not valid. It also does not have a constant velocity and is accelerating. There are several ways to imagine this motion. The frame could be traveling in a direction but be speeding up or speeding down. The frame could be traveling along the curved path but at the steady point. The frame could be traveling along the curved path but be speeding up or speeding down. This is how frames of reference is related to special theory of relativity. Thank you.